All right, so let's work on the next part. Here, we're going to work on a standard normal distribution and how can that help us answer these questions. So if we look at the first question here, it says the average admission charge for a movie is $5.81. If the distribution of movie admission charges is approximately normal, so the second we see approximately normal, we could kind of draw this graph over here. If the standard deviation is 81 cents, what is the probability that a randomly selected admission charge is less than $3.50? Okay, so this question's not too bad, but let's just see what we can do. So here, when we have a normal distribution, notice that the center is the mean, right? So this is the mean over here, and this is one standard deviation to the right, two standard deviations, three standard deviations, yada yada. And here, notice that the area under this whole entire curve has to equal 1, and that a z-value represents how many standard deviations away from the mean you are, and x is your data value, mu is your mean, and this symbol here, sigma, is the standard deviation. So having this information, how can we answer this question of the admission charge, right? So let's just go over it together again. Here, notice that the average admission charge, okay, so the mean, we know that the mean is $5.81, right? And here we also know that there's a normal distribution and that the standard deviation is 81 cents, right? And now it says, what is the probability that a randomly selected admission charge is less than 350? So let's just, draw our normal distribution, and let's just mark off the center. Our center is $5.81. And what happens if we go one standard deviation to the, well, actually, we don't even need to go to the right, because what's the x value here? It's $3.50, according to the problem. So we know $3.50 is somewhere to the left of $5.81. So let's see. What's one standard deviation to the left? It's at $5, because you're doing 581 minus the standard deviation. Okay, then what about the next one? What's $5 minus 81 cents? This will be $4.19, right? Because you're doing 5 minus 419. Well, then what's the next one? So, okay, so if we have 419 minus 0.81, that equals 3.38. So notice that this is one standard deviation to the left, this is two standard deviations to the left, and this is three standard deviations to the left. But we want to know how far to the left this is. What's the area under this? So here, notice that we don't have 350 here. But what we could do is, we can calculate the z-value, and this tells us how many standard deviations we are from the center. So here, we have all the information. So what is the z-value for 350? So here, we just say z is equal to x minus mu over the standard deviation, and we have these three values. So then here, x is what? Is 350 minus $5.81, and we divide it by the standard deviation of 0.81. And let's just put this into the calculator. So second alpha, let's make a fraction. So 350 minus $5.81, that's on the numerator. Did I just mess it up? Oh yeah, I did, my bad. Let me try that again. So alpha here, get a fraction, 350 minus 581, that's on the top. And let me zoom this in a little bit. Okay. And this is 0.81 on the bottom, so I hit enter, and I get negative 2.85. So negative 2.85, right? So now I know that this value of 350, which is somewhere over here, this 350, right, is here. And I know that the z value for this is negative 2. I know that this 350 is over here between the 419 and the 338, and this negative 2.85 is over here. So this is negative 2.85, right? I'm sorry, it's a little squished. But here, what's the question asking? We want to find the probability that a randomly selected admission charge is less than 350. So less than will show what is the area under here. That's the question we want to find. It's what is the area left or below of the z-value of negative 2.85. Because if we find the area to the left, it represents the probability of getting something within this whole area of 1. So here, to find this z-value, to find the area under this, what we need is our trusted z-value. So here is some standard z-value. If you don't have the same one I have, it doesn't make a difference. The values are still the same. So here, let's see. We want to find negative 2.85. So first, make sure that we're at the negatives. And here, we have to go to negative 2.8, which is right here. And let me see if I have a highlighter somewhere. Okay. I have a highlighter. So notice that it's at negative 2.8, but it's also at 0.05. So we want to find the intersection of this and this, and notice that this intersection is this. It's 0.0022. So the area over here is 0.0022. So then that means we have a 0.22%, a 0.22% chance that an admission ticket is below $3.50. And that's our answer. All right. I hope this was okay. All right, let's try and do the next question. So here it says teachers' salaries. Okay, so the average annual salary for all U.S. teachers is $47,750. So assume that the distribution is normal and the standard deviation is 5,680. So here, notice that let's first draw a picture that we have some normal distribution, right? And our center is here. And what is our mean? Our mean is, let me fold this here. The mean is 47,750, right? And now we know that the mean, okay, let me just write this down, is 47,750. The standard deviation is 5,680. It says find the probability that a randomly selected teacher earns between 35,000 and 45,000. So let's see. Notice that 35,000 has to be here. It has to be to the left of 47,000. And what about the other one? 45,000 is a little bit over here. So this is 45,000. So now the question is, how many standard deviations is 35,000 away from the center, from the mean? How many standard deviations is this 45,000 away from the mean? What we want to calculate is the area in between here, right? So that's the question, is what is this area? So we're going to take it step by step. First, let's find the z-value of 35,000 and 45,000. Okay? What I want you to do is pause the video, find the z-value for this, and find the z-value for that. Okay? And if you want to see how it's done, if you're coming back to the video, so this is our x value. So z is equal to x minus mu over sigma. Z is equal to x minus mu over sigma. And then we could, separate the two. And now here, our x value is 35,000 minus 47,750 over 5,680, and that's the same over here, but here our x value is 45,000 minus 47,750 over 5,680, right? And let's just put this into the calculator. So here, second y, make a fraction, 35,000 minus 47,750 divided by 5,680, and it gave me this. I don't want a decimal. How do I convert this to a decimal? Okay, let me just do this. -1275 divided by 568. Right, okay, enter. Okay, so I have -2.24. So this is -2.24. That's the z value for this. And here, what's the z value for this guy? It should be 45,000. All right, let's try it again here. 45, I can just do this. So 45,000 minus 47,750, whatever that is. So that's -2,750. So -2,750 divided by 5,680, and I get -0.48. So -0.48. So what do these two numbers represent over here? They represent the standard deviation. This is how far, here, let me zoom out a little bit. So these two numbers over here represent this teal value here. This teal value, this 35,000 is -2.24 standard, it's -2.24 standard deviations away from the center. And this one over here is -0.48. So this is -0.48. Okay, but how can we find, using the table over here, how could we find the area in between this? So this is where you have to be a little bit patient, so let me draw it out. Here, if we just have -2.24, what's the area to the left of -2.24? It'll be, let's do it here with this. It's that area, and we have to calculate it. So here we just have to go to our table over here. Where is -2.24? -2.24 is -2.2. So -2.2 is here. And let me zoom in. -2.2 is here. And then we go to 0.04 over here. And then here it is, boom, here. That's that value. So it's 0.0125. So this is 0.0125 is that area over here. Okay. What about the other one? What about what's the area to the left of -4.8? Okay, so here, -4.8 is somewhere here. This is -0.48. Okay, and then what's the z value for this? Well, I need to go to, let's see. It's -0.4. Let me zoom in. Let me zoom out. I have to go to the 8 over here. So it's 0.3156. Okay, 0.3156. So we know that the area for here is 0.3156. So notice that if we want to calculate this area in the green, right? This is the area that we want. Remember, if we go back to the problem, what is it saying? We want to find what's between 35,000 and 45,000. To find what's in between, we need only this part. So what we're going to do is we're going to take this whole thing and just minus this. If we minus this, then it just gives this represents this. So all we need to do is this minus that. So here we'll just have 0.3156 minus 0.0125, and what will this be? 0.30, what is it? 31, right? 31. Okay. And so what is this as a decimal? I'm sorry, as a percent, this will be 30.31%. And that's it. This number over here represents this area in the green, and that's what we want to find. So yeah, the chance that if this is the mean salary for a teacher, and this is the standard deviation, what's the probability that somebody has a salary, a teacher has a salary between 35 and 45,000? It's a 30.31% chance. Okay? All right, let's try and do the next one, and then we're done. Okay, this video is it's almost 17 minutes, but we can keep going. Hopefully this was good, but yeah, so let's look at the next problem here. It says, what's the probability that someone has more than 40,000? So if you want to have, let's first do this. Let's make our normal curve. And here, if we know that the center is 47,750, here, let's find the z-value of 40,000. So here we want 40,000. And here, what part of this curve represents more than 40,000? It's everything here, right? We want to find this area over here. All right, well, let's find the z-value of 40,000 first. So the z-value of 40,000, right? So z is equal to x minus mu over sigma, and this is z is equal to 40,000 minus 47,500 divided by 5,680, right? All right, so let's just put this into the calculator. Okay, so 40,000 minus 47,500, right? So that's negative 7,500 divided by 5,680, and that's negative 1.32. And that's the z-value, right? So now here, let's go back to our z-table over here. And where is negative 1.32? So negative 1.3 is over here. And what is it, 0.2, right, 0.2. So this is negative 1.3. This is 0.02. And here, okay. And that's the probability. But notice here that when you find a z-value, you're always finding the area to the left, okay? So just note, z-values table is only the area to the left. So what we just found that this 0.0934, this is 0.0934, right? The area to the left of 40,000 is 0.0934, but we don't want the area to the left of 40,000. We want the area to the right. And like I said before, that what is the area of this whole entire curve? So remember that if I have some curve, the area of the whole entire curve is equal to 1. So if I want to find the area of the red, I just have to do 1 minus the area of this green. So I just have to do 0.0934. And what will that equal? This is 0.66? Can I do math? Let's see, 1 minus 0.0934. Oh God, I can't do math. It's 0.9066. Okay, and then this represents a 90.66%. All right, so this is 90.66% that a teacher will have a salary higher than 40,000. Okay, class, I hope that helped. For the next question, just use the techniques. You see, this is more than 90,000. This is less than, oh no, this is also more than 75,000. And the mean and the standard deviation are a little bit different, but this is not too bad. You can try and do this one by yourself. I hope this helps. Good luck on the exam. Study hard. I'll see you there.